let us do some practice questions to check if we fully understand the process of finding two consecutive integers between a set, right, from the previous lesson that we've been doing. So we're going to do that by doing question 2. Question 2 reads as follows: without a calculator, determine between which two consecutive integers the following irrational numbers lie. Right? I mean, the question is straightforward because we explained each and every term on the previous lesson. Now, I will come here and answer this question 2 and jump straight to question 2.1. Right, when we look at 2.1, we can see that it's a square root, right? In this case, a square root of 2. That's the first thing that you have to notice. But after noticing that, the first step that we do is that we take our square root of 2 and we put it in between two perfect squares, meaning we're going to find two perfect squares that one that will be less than a 2 and the other one that will be bigger than a 2. The only perfect square that is less than a 2 is a 1 here. So that means here I'll put a 1. And the perfect square that is bigger than a 2 this side, right, would be a 4. Now, the second step to this question is that we have to then now put the square roots, because we are dealing with a square root. We have to put the square roots on both sides. So this is to say here that I have to put a square root on 1 and put a square root on 4. But we know that the square root of 1 is exactly 1. And here we still have a root of 2 and the square root of 4 is a 2. So this means that the number root 2, the irrational root 2, is a number that lies between 1 and 2, right? It is bigger than a 1, but not bigger than a 2. Question 2.2, we are looking at two consecutive numbers between the square root of 21. So we have 2.2 here, 2.2, and we are looking at 21. Again, I'm going to find two perfect squares, right? One that is less than 21 and the other one that is bigger than 21, right? Obviously, a perfect square that is less than 21 would be 16, you know. That is the one that is closer to 21. And the other one that is, bigger than 21 but not so far would be a 25, right? But we know that the second step would be us to put the square root, because we are dealing with a square root here. Remember, we were given a square root of 21. So that's why we have to put square roots this side. So this would be 21 and then less than 25. Obviously, you should know that the root of 16 is a 4, is less than the root of 21, is less than the root of 25 is a 5, right? And again, this is very important. If you look at this number and this number, they are consecutive integers, right? They follow each other from smallest to biggest, right? 4, 5, right? So that means a number that is between 4 and 5, right, will be this 21, the square root of 21. And in the same way, if you look at 1 and 2, they are consecutive, they follow each other, right? And they put the root 2 in between. If we look at 2.3, we are looking at the square root of 70. The square root of 72. The square root of 72. Right? Again, we're going to look for two perfect squares that we can put on either side. Now, if these numbers are getting to be big, and because here they say you should not use a calculator, I would suggest that you either memorize these perfect squares as I've explained them here so that you can see, or you can construct them, by multiplying each of these whole numbers by themselves, squaring them and finding the one that is closest to the number that you are looking for, right? Now, I know that the number that is less than 75, right, the perfect square that is less than 75 would indeed be 64, and the one that is bigger than 85 is 81. Like 9 times 9, would give me 81, and in this case is an 8 squared. It will give me 64, in which case when I put the square root on both these two numbers, I then get here an 8, and this side I'm going to get a 9. This is 72. You can see that these two numbers are consecutive, right, with each other, and this number means would be in between. If you take the root of 72, it will be in between those two numbers. This is your final answer. And remember now that I'm using the theorem that we spoke about to say if A, B, C are positive whole numbers and A is less than B and is less than C, then if you take the nth root of those numbers, they will also be in the same order, such that the nth root of A is less than the nth root of B is less than the nth root of C. That's what I'm doing here. That's why after I found these perfect squares, I actually take the square root of those numbers. And also that's why I look for a number that is less than 72 and a number that is bigger than 72, because I'm applying the fact that A should be less than B and B should be less than C. That's what we discussed in the previous lesson when we went through that. Just a reminder on that. 2.4, they say the cubic root of 5. They give us here 2.4. They say we have the cubic root of 5. We apply the same thing even if we have the cubic root. Remember that our theorem says the nth. It can be 2, 3, 4, and so on. Right? Now, if we look at 5, the closest perfect cube, because now here we are dealing with a cube root, I'm going to look for perfect cubes. The closest perfect cube would be a 1 to a 5, which is less than a 5. 1 is less than a 5, but the perfect cube that is bigger than 5 will be an 8. That is closest to 5 would be an 8. Now the second step would be me putting now the cube roots on these numbers that I've found, the perfect cubes that I've found, right? And 8 here as well. So that now we know that the cubic root of 1 is going to be 1, and the cubic root of 8 is going to be a 2, because 2 to the power 3 is an 8, right? So this means that this irrational number, this set, right, the cubic root of 5 lies between 1 and 2. And when we jump to question 2.5, they say the cubic root of 38, right? So we go to 2.5. We're having here the cubic root of 38, right? The perfect cube that is less than 38 will be a 27, and the one that is bigger than an 8 will be 64, right? Now, if I then apply cubic roots on both sides, this gives me a 3 this side, and this gives me a 4 this side, right? So this means that my cubic root of 38 lies between 3 and 4, right? Is a number between 3 and 4. The last question says we should find the cubic root of 155, right? So here we have 2.6. We are looking for the cubic root of 155. Okay, this question could be a bit problematic because here we are not allowed to use a calculator and it's a big number. But again, as I said, what you can do is that you can actually check all these numbers, square them: 1 squared, 2 squared, 3 squared, 4 squared, and you would see that if you continue doing that, you would get to a point where when you say 5 squared, right, it will give you 125, right? But when you say 6 squared, it will then give you 216, right? And you can clearly see that 155 is in between here. So that means my perfect squares, the one that is less than 155 and close to 155, is going to be 125, and here is going to be 126. So that when I then I can rewrite this the way they are to say this is going to be, okay, here these are cubes, are not squared, right? These are cubes because I'm looking for cubes. So if I write this in this fashion, it will then transform into a 6 to the power 3 as well. Now at this stage, I can then put my cubic roots on both sides, right? And obviously when we put the cubic roots, we know that this cubic root will cancel with that 3, so that I'm left with a 5 is less than the cubic root of 3. 155 is less than, now this cubic root will cancel with that 3, right? So that I have a 6 this side. So the final answer says that the cubic root of 155 would be a number that lies between 5 and a 6, right? So we know that number is between 5 and a 6. Now, without using a calculator, we can tell. Sometimes you can check these numbers using a calculator, even though they say you should not use a calculator. You can check your answers if they are correct by using a calculator. For instance, I can come here and find the cubic root. I can find the cubic root of 155, and I can see that I get 5.371. Do you see that 5.371 is bigger than a 5? But it's not bigger than a 6, it's small to a 6. You can check them after using this method without the calculator to see that you are in the right path.